Yeah, okay. So, hi everyone. Today we'll discuss Codechef Starters 165 and we'll discuss the first five problems of Division 2. Please don't annotate. Yeah, so we'll discuss the first five problems and okay, let's start. So, the first problem goes like, uh, okay. So, the first problem goes like, the shop has n items for sale. Ith item has a cost of AI. Okay. You would like to purchase all the items, all the n items, right? So the shop offers a discount. Whenever an item is bought, all future purchases have their cost reduced by one. So like all of the you get a discount of 1 rupee or $1, whatever, on the future purchases. However, the cost of an item cannot fall below zero, right? You can buy the items in any order. What is the minimum possible cost of purchasing all n items? So yeah, the problem is I think clear. I just explain that you basically you have n items. Let's say a1, like item 1 has the cost of a1, item 2 has cost of a2, and item n has cost of an. You want to buy all of these n items, and the shop has this policy that whenever you buy one item, the cost of all the other items, like the future items, gets reduced by one. Like, but they cannot be negative. They have to be greater than equal to zero, right? So we have to find out the minimum possible cost by which you can like buy the items, right? So let's take the samples. Let's take this one, like 4 3 1 4 1. Okay, so my array is 3 1 4 1. Now let's say I just buy them in this order. Then what will happen? I will give 3 coins to buy the first item. Then the second one, like the discount is right now is one because I purchased one item. So discount is one. So for the second item, I won't have to pay anything because there is one discount. Then for the third item, I will have a discount of two because I purchased two items. So I will have to pay two. And for the last item, I'll have to pay zero because I have a discount of three and it only costs one. So I'll have to pay zero. So in this case, I will have to pay 5 rupees or coins or dollars, whatever. And let's say I purchase them in this order. Let's say I purchase them like 1 1 3 4. Then what you can see is first I'll purchase it for 1 rupee. Then I'll pay zero because there is one discount. Then there is two discount, so I'll pay one for this, and there is three discount, so I'll pay one for this. So totally I'll have to pay only 3 coins. So as you can see, the number of coins that you have to pay, that is the cost, depends on what order you are choosing them in. So we have to determine the minimum possible cost, right? Okay, so the intuition to is the intuition to this problem is like what I thought was first, let's say we have a general array, right? So let's say we have a1, a2 up to an. Then what would be the cost? Then it would be like a1 for the first item. If I purchase it in this order, then what would be the cost? So if I do that, then the cost would be a1 plus a2 minus 1 because I have purchased one item. Assuming that a2 is greater than equal to 1 right now. Then plus a3 minus 2. Assuming that a3 is greater than equal to 2 and so on, I'll get up to um, an minus n minus 1. So this is the cost. And like this will come out to be summation of ai minus 1 to up to n minus 1, which is n into n minus 1 by 2, right? So what I am seeing is that if like every item is greater than equal to n, like this is my first observation that if ai is always greater than or equal to n, or let's say n minus 1, then it doesn't depend that in which order I take this. Like because for any order, the sum will be same. and this is constant. Like this doesn't depend on the order. So if the assumptions are valid, then for any permutation I take, like if this is true, then for any permutation, the cost will turn out to be this only. Like what I'm saying is that if the cost is big enough, then I will get the full discount of this. However, if like the cost is less, then I might not get the full discount. So what I want to do is maximize the discount, right? So to do that, I will greedily purchase the cheaper ones first, because if I purchase them later, it might happen that the discount might exceed the cost. So in that case, I'll lose out on some discount. Like if I say, they say I have 3141. So if I purchase them in like 4311, then at this point I have to pay 4. Then at this point I have to pay like 2, right? Then I have discount of 2, but I have only one cost here. So essentially, I am losing out on a discount of 1. Like if there was something else here, that is, so let's say there was 8 here, then I would have to pay 2 rupees less than the original. But right now, I have to pay 1 rupee less. So that means my discount has decreased. So that's not what I want. I want that I get the maximum discount. So therefore, I will save the expensive ones for later. So therefore, I will buy the cheaper ones first. That is, I'll sort the array like this. And then I will just calculate that what would be my cost. Like I'll sort the array like this, and then I'll buy the one, I'll buy the first one, 4 rupee one, then this 4 rupee zero, then my discount is 2, so I'll buy this one for 1 rupee, discount is 3, so I'll buy 4 for 1 rupee, so I will get 3. And as you can see that I didn't lose out on any discount. Like at this point I got 1 discount, here I got 2 discount, here I got 3 discount, because these costs were large enough so that I don't lose out on anything. So therefore I can like minimize my cost, right? So that's the approach, that we just sort the array and then go through it and find the cost. Like I think it is trivial to calculate the cost after sorting. Basically, what you can just do is for I from 0 to n minus 1, which means like I am at ai. So I'll just add the cost of ith element to my answer minus the discount. The discount will be I, because you can see it right easily. Discount will be I, ai minus I, I'll add. But if this is negative, like if it is positive, then I'll add. If this is greater than equal to 0. And otherwise, I'll just add 0. Like otherwise, I won't do anything. So this is the pseudocode for the problem. I think it should be clear. Doesn't anyone have doubt? All right. So I'll just show the code for a minute. Yeah. So this is the code. I just took the input of the array, then I sorted it, and then this is the answer variable. Then for I from 0 to n minus 1, I just added the answer with ai minus I or 0, whichever one is greater, max on this. And then I output it, right? So any doubt in the code? Okay, let's move on to the next one. All right. So the next one, it is called stable array. Okay, so let's read it. You are given an array A of length n. Every second, the following process will happen. It will happen, it's guaranteed. Okay. For each I from 1 to n, from 1 to n minus 1 in order, if ai is less than ai plus 1, set ai to ai plus 1. Okay. For example, if a is 31415, the process is as follows. If ai is not less than a2, sorry, for this one, a1 is not less than a2. Like 3 is bigger than 1, so nothing will happen. A2 is less than a3, like 1 is less than 4. So it will become 4, this thing. So, and like they explain the thing, I'll just explain it on whiteboard, like what will happen. So let's say you have array 3, 1, 4, 1, 5. So after each hour, what happens is, like at t equal to 1, what will happen? That like in these elements, 3 is greater, so nothing would happen. Then 1 is less than 4, so 4 will come here. Then 4 is less than 1, so 4 will come here. Then 1 is less than 5, so 5 will come. And last element won't change, like it will never change. That's the thing. Like we are doing this process only for I from 0 to n minus 1 to n minus 1. So nothing will change. So this is our array after t equals to 1. Then let's say for t after t equals to 2, what will happen? Basically, among 3 and 4, 4 is greater. So 4 will take over. Now between 4 and 4, they are same. So it's 4 either ways. Then 4 and 5, so we have 5. 5 and 5, we have 5 and 5. Then similarly, you can follow that this becomes 4, 5, 5, 5, 5, and this becomes 5, right? So at t equal to 3, this happens. T equal to 4, this happens. And for every moment after this, the array won't change. This is stable. Like that's what defined. That's what it is defined. A is said to be stable if none of its elements change after the process. So how many seconds will it take for A to become stable? So in this case, it took 4 seconds for A to become stable. So I think it is in the samples. Yeah, it is in the samples, and the answer is 4, right? So that's the problem, and we have to think about it. Okay, and should I take the test cases? Like, okay, I'll just take like this is 3, 2, 1, 3, 2, 1. So what will happen in this case? This is less than this, sorry, greater than this, and 2 is greater than 1. So nothing will happen. So this is already stable, right? Then for 1, 2, 3, what we have is 2, 3, 3. This will happen at t equals 1. And at t equals to 2, what will happen? It will become 3, 3, 3. So this is stable, right? Okay. So that's why the answer is 2. All right. So let's think about it. Like while I was solving this, the first thing I thought was, when will an array be stable? Like if I ask you, when will it be stable? So can you answer me? Can someone answer that? When will the array be stable? Amit says decreasing array. Do all elements equal? No, but Harsha, the thing is that we took 3 to 1 example. This is also stable, where like not all elements are equal. Non-increasing array, non-increasing array, non-increasing array. Okay. Yeah, decreasing. Okay, not decreasing. It can be non-increasing as well, like 3, 3, 2, 1. This is also uh, like stable, right? It is non-decreasing. So yeah, the condition for stable array is for it to become non-increasing. Okay, that's one observation. Like that's the one thing that I thought. Okay, then after that, what did I think? That how will the elements change? Like for example, let's take this example. This is nice. 3, 1, 4, 1, 5. So like look at this 5 here. Like after t equals 1, this 5 will become like go here, right? So this will become 5. Just look at the 5 for now. Ignore the other elements. Just look at this 5. Like where will it go, right? So after this 1 second, it will go here. Then after 2 seconds, it will go here, because this 4 will not be able to defend against the 5. Like since the 5 is greater than 4, then it will be able to reach there, right? This 4 will not be able to defend. Then uh, 5 will jump to here, and this one will become 5, and it will jump to here, so this will become 5. So in the final array, like Now I know that final array will become 5, 5, 5, 5, 5. But now let's say there was something else, right? Let's say 3, 8, 2, 5, and 4. Okay. So if you look at this 4, it will try to jump here, but it won't be able to do that because there is a 5 here. 5 is greater than 4. So therefore it won't be able to jump. So it will become like it will remain like 4 will remain here only. Then this will remain 5. Then we'll see till where can 5 jump. 5 can jump here because 2 is less than 5. So 5 will come here. But 5 can't jump here because there is 8. Okay, so nothing will happen to it. It will remain like this. And then 8 can jump here. So 8 can jump to 3. So it will become 8. Right? So that's what the final array is. Right? Does anyone agree? Like, does anyone have a doubt in this? No doubts? Like, this is how we can calculate the final array. Okay. Now, essentially, what am I doing? Like, let's take this again. 3, or maybe I can take another example. 3, 8, 2, 3, 6, let's say 1. So, if I ask that for this 6, till when can it go? Till where can it go? My word. Till where can this 6 go? So, you will answer that the element that is just greater than, like, the element that is greater than 6, the nearest element to the left of 6, which is greater than 6, it can go till that. Like, it can't go there, it can go till the previous of that. Like, right? Just like this boils down to the like previous greater element, nearest greater element to the left, whatever that is called. Uh, Nearest greater element to the left, right? I hope it is clear. If anyone has a doubt, then they can ask. Okay, so like basically that's one observation. Now, what I can say is that to for the six to get stable, like six has to cover these two, like 3 and 2. It can't cover 8. Six just has to cover these two. So if I ask that for just six, how much time will it take? Then you can easily say no, that it will take t equals like it will take 2 time for six to get stabilized because it just has to cover two elements. So after the first second, it will cover this element. After the second, it can cover this element, right? So it will take 2 seconds for six. Then let's say I ask that for 8, after how much time will it get like covered? So it has to cover this tree. So after just t equals 1, it will get stable. So basically, for every element, if we just compute that which one is its nearest element to the left, and like that will give us the timing, like the difference of indices will give us the timing that how much time will it taken for that particular element to stabilize, and using that we can just like take the maximum and we'll get the answer, right? Like I'll just show you an example. Like for example, let's just sample 31415. So for this 3, there like 3 won't change. Okay, 1 1 won't change because there is no element less, sorry. Yeah, so the greater element to the left of it is 3 here. So like it doesn't need any time to stabilize, like it is already stable because the greater element to the left of it is just like just next to the left of it, like it is just here. So 1 will need no time, 3 already needs no time because there is nothing to the left of it. Then 4 will need 2 time because it has to cover these two elements. So then we can say that the next greater element is at this index, like -1. This index is 0. This is 1, this is 2, this is 3, this is 4. And it at minus 1, let's say I have infinity. So we can say that the greater element to 4 is at minus 1. So it will take 2 time to stabilize. Then for 1, we can say it will take 0 time. And for 5, the next greater element is at minus 1. So it will take 4 time. So we'll just take the max of these numbers. We'll take the max of 0, 0, 2, 0, 4, and we'll get 4. It is n square. Actually, um, it is not n square because like I haven't explained how will you figure out the pH greater element. It is actually a very famous problem that finding the nearest greater element to the left. It is actually a standard problem. Like it appears in many job interviews, and it is a common problem on lead code. Yeah, you solve it using monotonic stack. I'll explain what that is because I think many people don't know here. So what you can do is um, you can use a stack. How will you use it? Use it like it is actually the technique is called monotonic stack. Monotonic stack. So what is it? Like let's say I have 3, 1, 4, 1, 5. So first of all, I have a stack, right? Right now it is empty. So first I'll insert 3. Like this 3, I will insert. Then I will insert 1. Okay. Then I come across 4. Like basically what I want is that this stack must be decreasing. Like, um, I mean, this is what I am trying to do. That is decreasing. So that's why first I just put in 3 in the stack. Then I put in 1 because 1 is less than 3. So it is decreasing. Then I come across 4. So now 4 is not greater than, like not less than 1. So I will just erase it. I'll erase this one and insert. Yeah, okay, I'll erase this one. But now I have this 3. So 3 is also greater than, not greater than 4. So I'll erase that also. And now I'll insert 4. Like, and what this means is that the previous element for 4 is 0. Like, I'll explain properly. Um, just a minute, guys. Okay, yeah. So basically we have 3, 1, 4, 1, 5. So actually what you can do is you can maintain a decreasing array, like stack or array, whatever. You can call it an array also if you are just using the end element. So or a vector, like whatever. So first you insert 3 into it, then you insert 1. So when you are inserting 1, you notice that this 3 is greater than 1. Therefore, you will mark the answer for 1 as 3, like the index of 3, which is 0. And since like when inserting 3, the stack was empty, so that means that there is no element greater than that. So it will just be minus 1. Then you will come at 4. You will look at 4 and you will say that 1 is not greater than 4. Therefore, I have to remove 1. So I'll just remove 1. Then I'll look at 3. 3 is less than 4. So I'll remove 3. And now I'll insert 4 because it is empty. And since I inserted it when it is empty, that means that there is no element which is greater than 4. Therefore, the answer to it will be minus 1. Then we have 1. So we'll insert 1 because it is less than 4. And like the answer for 1 will be 4, like the index of 4. So it will be 2. And then we come across 5, right? And 5, for 5 we'll just delete this one because it is less, and we'll delete this 4 and then insert this 5. And since we inserted 5 when the stack was empty, the answer will be minus 1 for 5. Like that's how you can calculate the index of the leftmost, like nearest element to the left, which is less than that. How will one be marked 2? It is because when 1 was inserted, we had 4, right? We had 4 in the stack, and then we inserted 1. So that means that 4 is the element which is just greater. So we'll mark the index of 4, which is 2. Like I am 0, this is 0 indexing, right? 1, 0, 1, 2, 3, 4. So I will mark 2 for 1. So that's how you will get the element which is just previous, like which is the nearest element to the left, which is greater. And after that, you can just calculate, like let's say left of I stores the, like whatever, like this array is left of I. This array is left. Okay. So left, I'll just do I minus left of I. Like for example, if we take this one, so index would be 3 minus 2 minus 1. Okay. So we'll just take this value, like this is the time that is required for element I to stabilize. For example, we have this 4. The left of it is minus 1 and index is 2. So it becomes 2 minus minus 1 and minus 1. So this will become 2, which means that 4 will take time 2 to stabilize. So we will just take the max of this value, and that is our answer. Max of this value, maximum across all I. So that's our answer. And on the formula, okay, like someone is asking, how did I get this formula? So that is the thing. Like, let's say for the ith element, I want to check. Okay, there is an array, and for this element, this is the ith element. I want to check then how much time will it take to stabilize. So let's say the answer for this, the left of I is this. What does that mean? Like what that means is that the just greater element to this one, like let's say here is a, or let's say here is 5. So what I'm saying is, if both of these are less than 5 and this is greater than equal to 5, like this is the element which is just greater than 5, like nearest to the left. So what I'm saying is, I just take the difference of these two indices, like this distance, but minus 1. Like we want these two elements, like we want 2 for this, right? So therefore we'll just take I minus left of I minus 1, right? So that's the thing. And yeah, there is one edge case. Like you have to notice one thing, that in case of equality, like let's say I have 3, 1, 2, 4, no, not 4. Let's say I have 2, and again, like, okay, this is what I have. So for 3, I'll mark minus 1, obviously. Then for 1, I'll mark 0. Then for 2, I will mark um, 3, like 0, right? And for this 2, I'll have to mark um, 2. Like for this 2, I will count this. Like basically, what I'm finding is the next, sorry, not next, nearest greater than or equal to element to the left. Like why I am doing this? Because this 2 doesn't actually need to go up till here to stabilize. It actually needs to just fill this gap, which is not like, which is 0 in this case, but it just needs to fill this gap to stabilize, because this 2 is also doing its work. Like you get it, right? That, like why I did this. It should be clear. Is there any doubt in this? Like why I did return equal to and not greater? Like why didn't I do this? Clear? Okay. So yeah, that was the problem. And I'll just show you the code. Like it's pretty simple if you already know the nearest left, like that problem, the start problem, that nearest left element. If you already know that, then it is pretty simple. So this is my stack. Like this is a vector. I am just using it as stack, and this it stores the first element. Like first element is the value, and second is the index of that value. So if it is empty, then um, I just do v dot pushback ai, and otherwise, while it is less, I'll just pop the elements and push the ai. And then after, actually, I am not considering those elements which are not in the vector. Okay, this is one good thing. I forgot to mention this, that let's say I have, um, let's say I have 5, 2, 3, 1, 1. So in this case, the final vector would be 5, 3, like the final stack. Like because first I'll insert 5, then I'll insert 2, then I look at 2 and 3, but 3 is greater. So I'll remove this 2 and insert 3. Then I'll insert 1, and then I'll insert this 1. So finally, it will become this. So I am just checking like the difference for only these elements. Like 5, 3, 1, 1. This is the vector. So I am not checking 2. Like I am not even checking the value for 2, because I know that the value of 3 will be definitely greater than 2. Like for both of these, the answer is 5. But since like this distance is definitely smaller than 3, so I'm only checking those which are finally in this vector. So it should work in that case. That's what I did. So the answer equals max of index minus this index minus 1, right? And then I printed the answer. Okay, there was one doubt which is got deleted. Never mind. So I think it should be clear. Should we move on to the next problem, or does anyone have doubt? Okay, I'm assuming it's clear. All right. So the third problem, reverse and alternate. A binary string of length n is said to be almost alternating if it can be converted into an alternating string by performing the following operation at most once. Choose two indices, L and R, and then reverse the substring from L to R. So this is like you can perform this operation, and it is called almost alternating if it can be converted into alternating string using at most one operation. So you are asked, like you have been asked, that you are given a binary string S, and can you make it alternating using at most one operation, right? So the question is pretty simple to read. Like you can select a substring of a string. Like okay, yeah. First of all, what is alternating? That it is like 1 0 1 0 1 0 1, or 0 1 0 1. Like there are the no two elements are same. No two adjacent elements are same. All of them should be distinct. Like alternating, that's what it means, right? So you have been given a string. Let's say you have been given 0 1 1 0, and you can choose any substring and reverse it. So you can suppose, let's say you choose this and you reverse it. So it becomes 0 1 0 1. So therefore you can make this alternating. Therefore this string, we can say that it is almost alternating, right? So that's what they're asking. They will give you a string, and you will have to tell them that is it almost alternating or not. So let's say samples. 0011, I just explain. Okay, not I didn't explain. 0011, you can just select this thing, and it will get converted into 0101. Then you have 10001. It is not possible to convert this into alternating by reversing some substring. Therefore, it's the answer to it is no. Then for 01010, it is already alternating. So the answer is yes. And for 1011, you can, sorry, 1001, you can reverse this one. So you will get 1010. So therefore, the answer is yes. Okay. So now you just need to tell them whether the string is alternating or not, right? So what can be done? Now, in alternating, the definition is that no two consecutive elements should be equal, right? So whichever elements are equal, like consecutive, if they are consecutive and they are equal, then they are problem. We don't want them in our string, right? Like for example, we have some elements 1 0 1 0 0 1 0 1 0 1 1 0 1 1. So like this group, this group, and this group, they are problematic because we don't want them in our string. So what can we do? We have to break them, right? So therefore, um, like we have to perform the operation such that these two break. That's how we have to perform this operation. So like in this case, it isn't possible to break all three of them, as you can see. Like if you take this subarray, then these two will break, but this one won't break. Then if you like, I think it is obvious, right? Like this, you can only break at most two. In this case, you can't even break these two because when you reverse this 101, it will still become 101. So you can't break these two. So my point is that if there are greater than two groups, like I am calling these a group, any two consecutive elements which are same, I am calling them a group. So if they are greater than two groups, then the answer is no. Is it clear? Okay. Now, um, let's say you have two groups. Actually, before that, I'll just tell how what I thought, like how I thought about it. So, like basically, I thought in reverse that I want to make the string alternating. So this is the alternating string. So uh, this is the alternating string. Yeah, and I just thought that from where can it come from? Like basically, if I had reversed some substring and I got this, then I'm just thinking that what are the possible strings that I could have used to get this. So how do I think about that? Basically, I just reverse some substring in this. Like I just choose any substring from this one and I reverse it. So like if I reverse this, I will get 101, 10, 10, 0. So if I reverse this, I'll get this. So what that means is that if I have been given this string, then I can go back to this string by just reversing this one. Like this is my thought process. That's what I was thinking during the contest. Like from which different combinations can I come back? Can I come back to this alternating string? So this is one possibility that these are these two groups. This is 1 1 and this is 0 0, and I just break the string like you in this, like I just reverse this substring. So all of both of these groups will break. Then I thought that what if it is like this 1 0 1 1 0 1 0 1 1. So in this case, the two groups are same 1 1 and 1 1. So in this case, it is pretty easy to see that they are not, like we cannot break them. If we do this, then it is just same. They will not get broken. So Basically, I just proved that if there are more than two groups, then the answer is no. And if there are two groups, then if they are of the opposite sign, like if they are opposite, let's say one is 1 1 and the other one is 0 0, and they are the only two groups in this string, that means that after here will get 0, here will get 1, here will get 0, here will get 1, here will get 0, here will get 1. Like only this can be only this can be possible, because these are the only two groups. The other string is alternating, like entirely the rest string, it is alternating. We can like determine that because they are the only two. So we can just take them and flip. So in case of two groups, if they are the opposite, then the answer is yes. They are opposite, then yes. Okay. Now we had greater than two groups, false. Equal to two groups, yes if opposite. Now what if we have one group? If we have just one group, what does that mean? Like 0 1 0 1 0 0 1 0 1 0. Okay. So for this one group, what we can actually do? Actually, you can notice that wherever we keep the partition, like if we keep the partition here and here, so like if we keep one of them here, like this won't change anything because um, this is palindrome. And if we keep this one here, then here one will come. It will become 1 0 1 0. So now this is a problem. So like my point is that you should always keep partition there where there are problems. Like for example, in this case, we were keeping one partition here and one partition here, because the thing is that if you keep a partition somewhere where there is not a problem, like if you keep one here, then it will create a problem there. Like it might create a problem there, so therefore it is not feasible to put it there. So basically in this case, if you have something like 0 1 0 1 0 0 1 0 1 0, then you will put one here, and let's say you have one, let's say you have one this, then you have to put one partition at the end, then you can reverse the string, so it will become 0 1 0 1 0 1 0 1 0 1, right? So since there was this one here, and sorry 0, so I just use this one here and reverse this substring, and therefore I fix this 0 0. Like if I had chosen something else, like for example 1, like if I had chosen here and here, then this pair won't be fixed because this 0 will come here and it won't be fixed. So my point is that if we have only one group, then it would be of either 0 or 1, right? It is either of 0 or 1. Let's say it is of 0. Sorry. If it is of 0, then basically I need to have one end of the string non-zero. Like either of these two ends, they have to be 1. Like either both of them or at least one of them have to be 1. If they are both zeros, then I cannot possibly reverse any subarray to break this 0 0. And if one of them is 1, let's say this is 1, or uh, let's say this is the end, then I can just take this one and reverse this to break this 0 0. So that's what my point is, that for one group, like I can't, like okay, for one group, if it is of 0, if the group is of 0, then either of the endpoints either of the endpoints uh, should be non-zero. And if it is 1, then the vice versa. Either of the endpoints should be non-1. Like this should be 0. That's the observation. That if you have just one group, then the endpoints matter. Okay. And what if you have zero groups? Like we took the case of more than two. More than two we have done. No, like it can't be possible. Then in two, if they're opposite, then we can do. And if in one, we can do if the endpoints are not the same as the group. And for zero, if there are no groups, then what does that mean? Tell me, guys. If there are zero groups, then that means that there are no elements adjacent to each other which are equal. Yeah, it is already alternating. Like there is no element such as like there are no zero zeros or sorry, there are no zero zero or zero one. Sorry, one one. There are no zero zero or one one. Therefore, the string is already alternating. So zero one, like it will be already alternating. So it is possible, and that's the solution to this problem. Is it clear? Yes, clear, clear, very clear. Okay, thank you. Does anyone have a doubt? I don't mind explaining once again. Okay, it seems no one has a doubt. So I'll just show you the code for the sake of it. Please repeat once. Which part do you want me to repeat? Okay, there is one problem. Like there's one question. If 0 0 0 is there, okay. Let's say we have 1 0 0 0 1 0 1 0. So in this case, there are two groups of 0 0. Like, this is one group. This is another group, and our algorithm will detect that these two groups are equal. They are same. They are both same. So therefore, it will print no, and it should print no, right? Got it. Second portion where you alternate 0 and 1 in last. Second portion. Are you talking about like if there are two or if there are one? Like which part do you want me to repeat? If there are two or one or zero? Zero. Okay. So if there are zero groups. I'll just define what a group is. Like I'll repeat what a group is. A group is an occurrence of 0 0 or 0 or 1 1. Either if it is 0 0 or if it is 1 1. Like if any of these two appear in our string, then I call them a group. And if there are zero groups, then that means in the binary string there are no groups. Then that means all the elements are like alternating only, like 0 1. Like my point is that if there are zero groups, that means that the string is already alternating because it doesn't have any 0 0 or 1 1. So we don't need to do any operation on it. Actually, in the problem, it says that we can make at most one operation. Like we don't need to make an operation. We can do it we can do it or not do it. So in this case, we'll just choose not to do any operation, and it will be alternating. So this is also already alternating. So we'll get yes. Okay. So yeah, let's look at the code. It is pretty simple. First, I'll make this vector. Like this vector stores the indices where the groups are. Like for example, uh, one group is 10 1 0 1 0 1. Then the indices are 0 1 2 4 5 6 7 8. Right. So one group is at here and the other one is at here. So the vector will store the left indices, like this index and this index. It will store 3 and 7, and then I'll just use them later in the code. So if s of I equals s of I plus 1, then I'll just push back I in vector. Then if number of groups is greater than 2, then I'll see out no. If it is 0, then it is already alternating, so it is yes. If it is 1, then what we need is that one of the endpoints should be not equal to that. Like index is v of 0, like v has only one element, and index, I am storing that in index. And if s of index is equal to s of 0 and it is equal to s dot back, like both the endpoints are equal to that group, then I'll see out no. Otherwise, at least one element is not equal, so I'll print yes. And otherwise, like greater than 2, 0, 1. So what remains is 2. So if there are two groups, then they have to be distinct. That's what the condition is. So if s of v0 is not equal to s of v1, like these are the indices v0 and v1 of the two groups. So if they are not equal, then I print yes, else I print no. Okay. Any doubts in the codes? In the code? Okay, I am assuming that no. All right. So let's go to the next problem. We have A to B. The problem is named A to B. You are given 2 points, x1, y1, z1, and x2, y2, z2 in the 3D coordinate system. You would like to start at point A and reach at point B. To do this, you can move in any direction, up, down, left, right, front, or back, one step at a time. Formally, in one step, you can choose exactly one coordinate and either increase or decrease it by one. Okay. However, you are not allowed to move more than k steps consecutively in one direction. So we have to determine what is the minimum number of steps required from A to B. Okay. So like yeah, the problem is, I think it should be clear what the problem is. Just a second. Yeah, the problem is that you have been given 2 points, uh, x1, y1, z1, and we have to go to x2, y2, z2. So and also we cannot do more than k of the same operations. We can do up to k same moves, but we cannot do more than k same moves. Like if k is 2, let's say k is 2, then let's say we are moving up, then up. Then we can't move up again. We can't move up again because k equals to 2. That's what k means, right? So we have to go from this point to this point. Let's just take numbers. It will be much easier if I take numbers. Let's just take sample test case. Sample case 1 is 1 2 3 6 2 3, and k is 1. 1 2 3 to 6 2 3, k is equal to 1, right? So k equals 1 means that we cannot move more than one step in the same direction consecutively, which means that if I move in a direction once, I can't move in it twice. So let's see what can we do. What we have to do is basically you can see that 2 and 3 are same. Like we don't have to move in the y and z directions. We just have to move in the x direction. We have to move x in like we have to move 5 in positive x-axis. We have to increase exponent by 5. So ideally, what we want to do is move in the positive direction once, like move in that direction 5 times. Like that's what the shortest path is. I mean, not the it is the like it would result in the minimum operations. Like it would be 5 operations. But here we have another constraint that we cannot move more than once in the same direction. So this is illegal. Like we are moving twice in the same direction, and we can't do that. So we have to add kind of a padding in between these plus x's. Like since they are consecutive, we have to add a padding. What does that mean? That let's say between this plus x, I add a plus y. I can do that because I can make a new move. Like it is not consecutive. Then I can like basically I just added here I added plus y, right? Then plus x. Then let's say I add minus y. So the effect of these two will nullify. Then again I'll add plus x. We have three x's, this and this. Then I'll just add plus y in between these two. Then I'll add plus x. This is this plus x. Then I'll add minus y, and then I'll add this plus x. Like I hope you understand what the notation is. Like plus x means that I am moving in the positive x direction. Like I am increasing the x coordinate by 1. So ideally what we want that we increase the x coordinate by 5 times, but we can't do that. So we'll insert some extra moves in between these x's so that uh, this restriction is not like we have to respect this restriction, right? So therefore we have to do this. So in this case, I took 1, 2, 3, 4, 5, 6, 7, 8, and 9. I took 9 moves, and I think it is pretty clear that why we can't go less than that, right? So this is how I got the answer to the first test case as 9. Then let's say we have this one 1, 1, 1, 2, 2, 2. We have to move from 1, 1, 1 to 2, 2, 2. So ideally, what we want is x, y, and z, like plus x, plus y, and plus z. And we can just do this because and yeah, k equals to 2 in this sample. So we could even do the same move twice. We are allowed to do that, but we have to just do it once. So this works. So we just need 3 moves to do that. So that's what the problem is. And how will we solve it? Okay, that's a nice question. So let's see. So basically, what I want to say is that in ideal case, like here I had to move from 1 to 3 to 6 to 3. So um, I had to move 5. Like ideally, I would have to move 5 if the restriction wasn't there. Like I have to move at least 5, no? I have to have at least 5 of these plus x's. Otherwise, I can't reach there. So in the minimum case, I have to have those moves. Like for example, if I want to move from 2 comma 3 comma 4 to let's say 4 comma minus 1 comma let's say 6, then I have to have 2 plus x's, uh, 4 minus y's, because I want to decrease y by 4, and I need to have 2 plus z's, right? So I am saying that in this sample test case, regardless of the value of k, at least the answer would be 8. Like at least it can't be less than 8. That's what the point is. Do you all agree to this? Yeah. Okay. So in this case, let's say k equals 1. So what will we do? Any ideas? Like, how can we arrange this? Yeah, and like obviously I can reach there independent of order. Like if I shuffle this in any way, I'll reach there. Like my destination doesn't depend on order. Okay, you are asking why 4 times minus y? Because I want to go from 3 to minus 1 in the y direction. So therefore I have to decrease y 4 times. So 4 times minus y. Okay. So let's say k equals 1. Then how would you arrange this so that let's say we don't want to use any extra moves, we don't want to use any padding, like because for each extra move we will have like our answer will increase, but we want to minimize it. So how will you? Okay, so someone has written minus y plus x minus y plus x minus y plus z minus y plus z. Yeah, for k equal to 1, x and z gaps between 4y. Yeah, exactly. So what you will notice is that you can just take these 4y minus y, and between here, like you can insert the rest of them. You can insert this x here, then this x here, then this z here, and like now you can just insert this z somewhere else, like suppose here, right? So this is how you can do this without using extra moves. So therefore the answer would be 8 in this case, and it can't get better than that, right? So that's what my point is, that basically we just take the maximum, like here in this case the maximum occurrences of y comes 4 times. So we'll just take the maximum occurrences, we'll just put them, but since we don't want more than k in each group, we have to divide them. Now let's say k was 2. If k was 2, then we could just divide them into two groups, because we can do two consecutive moves. Like these two can be together. We don't need them to be different. Like we can have that they are different, but in the worst case, they can also be the same. So, like for example, if I just had, let's say the test case was 1, 3, 0, and 2 minus 1, 0. So in this, and k equals to 2. So in this case, I have um, plus x and 4 minus y. So I just want to arrange them, and where k equal to 2. So what I can just do is I can just put these 4 minus y's, but I can't have 4 minus y's lagatar, like in consecutively. So I'll just make them into two, like groups of two. We have k equals 2, right? So we have to make them into groups of two. So I'll group them into two, like this, and I need something here, a separator. So I'll just put a plus x here. Cool. So that's what we want to do. But like, what if there are two more plus x's? Like, let's say we have this. Like, let's just we add something like 1 to 4. Then we could just insert them between those minus y's. Like, because I can insert them all of them here. Like, if I do this, like all three of them one after the other, then this would violate the k equal to 2 condition. I am using 3 at the same place. But I don't need to do that. I can just, what can I do? I can just insert them between the minus y's. Like, because now, like for k equal to 1, that would work. Like right now, k equals to 2. So that means we can have group of at max 2. But we don't need them to be 2, right? We can have less also. So we'll just put these extra ones in between those minus y's. So my point is that in the worst case, I would have to select the maximum. I would have to place them. Let's say I place these, and then I would have to make groups of k. So let's say k equal to 2. Then these are the groups, and in between I would add padding elements if I have enough of them. Like, so what do I have is basically I have three directions: x, y, and z, or x, y, and z. So whichever one is the greatest, I'll just put them. Let's say x is greatest. So I'll just put all the x's here, like whatever they are, negative or positive, whatever they are. I'll just put them. And if I have enough y and z for the padding, then I'll just put those as padding. And if I am left with some extra yz, then I can always put them in between the groups. Like that is always possible because we need at most k, not exactly k. So we can always put them between the x's. So what I'm saying is you can just put the x's because they are maximum. Then you can calculate that how many groups will you need. Let's say we have seven x's and k equals 3. Or k equals 2, yeah, okay, 3. So we have 1, 2, 3, 4, 5, 6, 7. So group will form like this. So we need two partitions. To generalize this, if you have, let's say, capital X amount of x's and capital and k is some k, then how many groups will form? Can anyone tell me how many groups will form? XX, like basically you have x occurrences of x direction. Like in this case, you had seven x's. I am asking you, what if you have x axis? Like, let's say not x. Let's say you have p occurrences of x. Like p is a number here, and you have p x times. So what would be the number of groups? P by k. Seal of p by k. Yes, that's correct. Right? Yeah. X plus k minus one by k. The same thing. Okay. So I think you got it. That there would be seal of p by k groups, and how many dividers would we need? This minus one, right? For three groups, we need two dividers. So therefore, we need this number of dividers. And if we have enough of them, like x was maximum, so we also have y and z. So if y, like the count of y plus the count of z, if that is greater than or equal to this, sorry, if that is greater than or equal to this, then we won't need any extra move. We won't need any extra move, and in that case, the answer would be just absolute. Like the answer would be just x plus count of x plus count of y plus count of z. But what if we do need extra moves? Like, what if this value exceeds the sum of y and z? Like, for example, let's say I have seven x's, one y, and I don't have any z, zero z, and my k is let's say k is 2, right? So in that case, I'll just place the x's 1, 2, 3, 4, 5, 6, and 7. I'll make groups of 2, I mean plus x, whatever the direction is, this and this x. And I have to put the padding y. So I'll put this one y here, but I also need padding here and here. But I don't have enough elements to do that. So what can I just do? I'll just add, like, what I can do anything, like I can just add plus z and minus z here. So basically I need two extra elements to fill in the padding. So my answer would be this 7, like 7 x's I need, one y I need, and two extra I need. So 7 plus 1 plus 2. So I need 10 moves to go to that point. Someone is asking how x plus y plus z. So see, what I said was the number of padding, that is let's say the highest is x. Let's say we have capital X, x moves, capital Y, y moves, and capital Z, z moves. And let's say this is the highest, x is the highest. Then we would have ceil of x by k groups, right? And this minus one number of dividers. But if we don't, if we have enough, like if capital Y plus capital Z, if that exceeds ceiling of x by k minus 1, then basically we don't need an extra. So we just need the minimum number of moves that we would need. Like since you have x-axis, y-y's and z-z's, won't y and z also need dividers? No, actually, we can just insert them in between the x. Because x is the largest, we can just place them in between the x's. So they won't even there won't even be two consecutive. Let alone k, there won't even be two consecutive elements of y and z. Like because x is greatest. So what we know is that y y is less than x and z is less than x. So since we have, but if they are too large and cannot fit among all the axes, no, I am taking the largest as, like I am first placing the largest ones. Like I'm assuming that x is the largest. But if like whatever the largest is, I'll place that first. Suppose y is the largest, then I will place the y's first, and then I'll place the x's and z's among these y's. Like what my point is that if y is less than x and this is less than x, then I always have a way of putting them and no two of them will be together. I'll just prove that how. Let's say we have x axis, like I just put x axis. So how many y's can be there? At max, they can be like less than equal to, let's say. At max, they can be equal to number of x's. So I'll just put them behind this x. And let's say the z also in the worst case, we have less than equal to x. Like in the worst case, they are x. So we'll just put all of them after this x. So it's always possible that we can put them between the x's such that y and z will never form groups of more than k. Like I always have a way to do that. But if I have like too few of y and z, then that may happen that I am not able to make groups of k for x. Like y and z can't be too large. Like I'll always have a way of putting them. But the problem will occur when I have too few of them because there are not enough barriers between the x's. That's the thing. Understood. Okay. So yeah, I was saying that if we have, if we need extra, so how many extra will we need? Like I'm right now, I'm assuming that x is the highest. So basically the number of the borders is capital X by k and minus one. So this is what we the number of border is, and minus x plus y, sorry, minus capital Y plus z. So this is what the extra is. This is equal to extra. Okay, guys. Now, the thing is, there is one edge case here. Let's say, like, at this point, I ask myself, like, how to put this extra? How do I choose this extra? Yeah, if extra is odd, then we need another one. Like, let's say x is 3, x, and we have one y, k equals 1. So we will put the x's first, then I will put y. Now here, I'll need to put one extra. So let's say I add plus z. But to cancel out this plus z, we need one minus z as well. Minus z as well. Because we need to reach that point now. If we didn't have plus z originally, we would have to cancel it out. So we need extra one. Like in the extra also we need extra. So if the number of extras are odd, then we need one more of them. Otherwise, we need uh, that many, exactly that many. Is it clear? I hope it is clear. Any doubts? Clear. Okay, guys. So yeah, this was the problem, and like I'll summarize it. That first you will check the highest, you will place them, and you will check if there are sufficient dividers or not. If there are sufficient dividers, then you can just print the answer as a sum, and otherwise you can just check the how many extra you need, and you can print according to that. So I'll just show you the code. The code is this. Actually, I just changed the name of these variables. A, B, C, D, E, F, G, right? Then I'm defining x to be a minus d, that is the number of x's, the number of y's, the number of z's. And to find the highest, I just sorted this array. This is just the trick. I sorted this array, and what I did here, yeah, now number of groups, this is group, like the seal of highest upon g. I hope everyone knows how this is, like why did I do AR0 plus G minus 1 by G. I hope everyone knows that why this gives a ceiling, or that this gives a ceiling function. Okay, and extra, I need number of groups minus 1 minus minus y plus z, right? And if extra is less than or equal to 0, then I'll just print x plus y plus z. Otherwise, I'll have to print x plus y plus z. I need anyway. Then I need extra, and then if extra is odd, then I need one more. So I just did extra percentage 2, like extra mod 2. Okay. So I hope it is clear. We took y plus z and not seal of y plus z by k. Yeah, we took this when calculating required extras because we want to fill as many possible gaps with available y and z. Yes, you are correct. Because we want to fill all the gaps. We want to fill the gaps with the x, y, z, x and z that y and z that we have. So like greedily we have to just use one in each gap. We won't use k in each gap. We'll just use one in each gap so that we can use the minimum number of extras. Okay. Anyways, so yeah, this was the problem. Any doubt? Anyone? By minus one in dividers. Uh, because just a minute. Yeah, because this group, this group, this group. Let's say this group. You have four groups. So you need to divide only this. Like you only need to put the dividers here. So if there are four groups, you need three dividers. Okay, cool. I hope it is clear. Anyone doesn't have a doubt? Clear. Got it. Got it. Okay. Okay. So let's move on to the last problem of the day. That is, I forgot the name. Reverse and alternate count. Yeah. So this problem is a variation of the problem that we did previously. Like in that problem, we had to just check if a string is almost alternating or not. But in this one, we have to count the number of substrings that are almost alternating. Like the difference is just that we have given a binary string S. So how many substrings are almost alternating, right? So if you had done the previous one, then this one will use ideas from that one, right? So I'll just summarize the previous one quickly, like what were the results. Basically, what we had concluded was that if the string s, if it had more than two groups, then it can't be possible. Then the string s is not almost alternating. Then if the string s has two groups, then they must be opposite. They must be opposite. If it has only one group, then um, the endpoints, it's like the endpoints must not be equal to the group. Endpoint should differ, right? For one. And if there are zero groups, then we have that it is always possible. All right. So this was the conclusion. Now I'll start from here in this problem. So what we have to do is we have to count the number of substrings, right? So actually this is kind of similar to a problem that I saw. Like I'll just show that one and I'll ask you guys how to solve that, right? Okay, so the problem is given an array A of length n. Find number of subarrays containing at least one k. Like k is a number that we have been given. We have been given an array of length n and we have been given k, and we need to find the number of subarrays which contain, or let's say exactly one. Actually, it containing exactly 1k. Sorry. I- It contains exactly 1k. So the problem is this. Given an array n, find the number of subarrays containing exactly 1k. So how will you solve it? Any ideas? Like, has anyone solved it before? Or does anyone have an idea about this? I can also unmute them if you want. What do you mean by k? K is a number which, like, we have been given a number. We have been given a number, and like let's say the array is 2, 3, 4, 2, 4, and we have been given k equals to 4. Then what this question means is that count the number of subarrays of this array having exactly 1, 4. Two pointers. How will you do it in two pointers? Let me think about it. Like, do you want to explain how will you use two pointers? If someone wants to unmute, then I'll allow them to unmute. Just tell me in the chat. I want to try. Okay, I'll unmute you. Just a minute. If I'm able to do that. Yeah.
For example, maybe if we
Sorry,
consider
I can't. Your voice is a bit low. I still can't hear you. Actually, okay, someone wants to know the problem. Actually, let's leave it. I'll just um, ask for ideas. I'll explain the problem myself. Problem is given an array A of length n. Find the number of subarrays containing exactly one k. So, for example, in this array, you have to find out the number of subarrays. Can we just count the number of subarrays where we can't count and then count the remains where it will be there? This is what someone has written, and I can't understand what they mean. So, can you just use proper, like, I can't seem to understand what you mean. Can I unmute? Sure. Just a minute.
Okay, so what I am saying, am I audible?
Yeah, yeah, yeah.
So what I am saying, like just using two pointers, what we can do is just we can count the number of subarrays where we specifically can't find four, like k, and then we can just subtract them from 2 to the power n. That is the number of subarrays that is possible. So we will.
But that will give you at least one, like, that will give you the number of arrays which having at least one four. I want exactly one four.
Okay. Okay. Got it.
Yeah. Uh, Someone is saying after every new encounter of k, we'll add our count. Count is the length of current subarray. We'll add its length to our answer. Both sides of k. I'm sorry, what? Like, we'll add its length to our answer. After every new encounter of k, we'll add its length to our answer. We'll add count. Sorry, I can't seem to get you. Okay, someone is saying less than equal to k minus less than equal to k minus 1. Yeah, you just okay. No, wait. What? I think you understood the problem wrong. The problem is that given an array, let's say this, find the number of sub-arrays having exactly one k. Can I unmute? Okay, guys, actually, this is taking too much time. I think I should just explain it now. Yeah, yeah, okay, I'll just explain. So the thing is, basically, what you can do. I'll take a better example. Let's say k equals 4, and you have been given an array which is 2, 3, 4, 6, 8, 10, 4, 9, 8, 4, 4, 8, 4. All right. So you have to count the number of subarrays having exactly one 4. So what I can do is check this 4. Okay. So let's say this is the 4 that is appearing in my subarray. Like, basically, I count the number of subarrays having this element as the 4. So what can I do? For obviously, like, I have to choose an L and an R. So, like, L means that we will start from here and R means we'll end at here. So I am asking that where can I start from? I can start from either here, here, or here, and I'll end at either here, 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 here. I can't end here because in that case there will be two fours in my array, and I don't want that. I just want one four. So therefore, I can take L from these three values, and I can take R from these four values. So basically, there are 3 into 4, which is 12 combinations of L comma R that I can take. So the number of subarrays containing this 4 are 12. All right, and that's what we can do. We can do that for all the fours. Like for this 4, we can take L as here, 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 or here, and R as here, 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 here. So it will be 16. Like, that's how you can perform the operation. But how will you do it in O of n? That's the question, right? So you can easily do it actually. You can just make a vector which stores all the indices of 4. Like for example, in this case I'll make a vector v which stores 2 because 4s are 2. Then it is at 3, 4, 5, 6. Then it is at 7, 8, 9. It is at 9, right? It is at 9. It is at 10, and it is at 12. So this is all the positions of v. So yeah, you can do it while traversing by maintaining two variables. Yeah, that's true. Like you can just um, store the previous and the next one, and like that's what I'm saying. That if I store a vector, like okay, you can do it using just two variables. But if you use a vector, let's say, and you need to find corresponding to this four, like the sixth element, which is four, you need to find the answer for that. Then what you can do is, what does this two mean? That the four that just came before this one, like just before this one came, right? So what I can say is I can take any index after this four, like after this previous one, I can take any index like out of these. So if I want to calculate for this six, then the number of possibilities for L is just I can take any index after the previous one. Like previous one is two, so after the previous one, I can take from three up to six. I can take L here, and for R, the same thing. I can take R from six to eight. So six to yeah eight. So after multiplying, like this is of length four, this is of length three. So we will get 12 subarrays for this six, and that's like we can do that for every element, but we have to be careful. Like how do we handle the first and last element? Because they don't have anything before them. So if like this 2 doesn't have anything before it, that means that we can just start from 0. Like we can take any element from 0 to 2 for L, and for R we can take 2 to 5 because on its right we have 6, so we can't take 6. So we can just take 0 to 2 and 2 to 5. And for the last element we can just take anything on its right. So the size was okay, it was 12 like 12 11, 13 only. So we can just take 12 to the last element, which is 12. So for the for this wait, I'll just erase this thing. So for this last last four, we can choose the lower limit as either 11 or 12, and the upper limit as 12 to the end of the array. And in this case, the end of the array is 12, so like 12 comma 12. But yeah, that's what I mean. And so you can just iterate over this vector and add the answers corresponding to each element. And obviously, we don't need to store the vector. Like we can just iterate over the vector, and we can keep the second last position of the element k, the last position of the element k, and the current position, and then we'll just add the answer. Like that's tougher to implement. I just do it using vector. That's what I told. That's why I told you using vector. So I hope it is clear. This problem is clear. Any doubts for this? Clear? Okay. Nope. Thanks. Okay. Okay. So yeah. So actually, once you know this problem, the Codechef one becomes a bit easier. Like it is still little bit trickier, but it is easier as compared to when you didn't know this, right? So let's get to it. What we have is um, we have a string, right? We have a binary string, which means it contains zeros and ones, and we want to count the number of almost alternating substrings. So we just saw that, like actually, yeah. We just saw that if there are more than two groups, then it is not possible. If we have two groups, then they must be opposite sign, then it is possible. If we have one group, then that endpoint must be different. And if we have zero groups, then it is possible. How would the answer for the question you gave change for at least 1k? Okay, so like if the question was at least 1k, then how would you solve it? Yeah, that's also a question. Like basically in that case, what you would do is that you would calculate the answer for 0k. Like all the sub-arrays, you'll count the sub-arrays which don't have any occurrence of k. So how will you do that? You can do that by like seeing that, let's say, actually I'll have to clean some of it. This is the array. Just a minute. Yeah, so uh, we have fours here, like k is equal to 4 in this case. So if we want to count the number of sub-arrays having at least one 4, then what we can do is we can count the number of sub-arrays which don't have any 4. And how to do that? We can just observe that whatever L and R we take, we can't take them such that there is a 4 between them. So basically these 4 act as a barrier, like in the sense that either both L and R should be the left of it or to the right of it. So all of these fours, they act as a barrier. You can't put L and R across them. Like either they should be left of them or to right of them. So basically you have some regions. You have these regions and you can choose L and R among them. So that will give you the number of subarrays which don't have any occurrence of k, and you will just subtract them from nc2 plus n, like n plus 1 c2, which is the number of subarrays, and you will get the answer. Okay, we just went a bit off track there. Coming back to the problem that we have in our hand, we have that we have been given a string, and we need to count the number of substrings which um, which are almost alternating, right? So for that to happen, either the substring should have two groups and they're opposite, or it should have one group and it's not the endpoint, or it should have zero groups, right? That's what the thing is. Like that's what I've observed, that this is the condition for a string to be almost alternating. So we want to count the number of substrings that satisfy at least one of this condition, like at least one of this condition, right? So how will I count that? I have to count that. So my idea is that I can count these types of arrays, then I can count these, I can count these, and then I'll just add them. I can add, like that's what I'm going to do. That I'm going to count the number of subarrays which have two groups and which satisfy this. Then like that will be added to my answer. Then I'll count the number of subarrays which have one group and this condition. So I'll add it to my answer, and then I'll count the subarrays which have zero groups, and I'll add that to my answer. So how do I do that? That is the question. So I have three cases to handle, and I'll handle them one by one. I'll explain them one by one. All right. So the first case, first case is that you have two groups and they are opposite, right? So you have to count the number of subarrays satisfying this condition. So how will I do that? Now, yeah, if you remember correctly, that I had made a vector. Like if you see, I actually had a vector in this, which stored the occurrences of 0, 0 and 1, 1. Like it just stored all the indices of a group, right? Like this V vector, it stored all of the occurrences of a group, the indices, and also, yeah, right? So in this part also, I'll just make a vector. I'll make that vector, which stores the indices that we have as a group, like the indices for which SI is equal to S of I plus 1. So uh, I have this vector which contains all of these groups, right? And also actually it is a pair, like it is a vector of pair, and it contains, or actually we don't need, never mind. So it is a vector which contains the indices of these groups. Now let's say we need two groups of the opposite size, of the opposite like sign, let's say. So I'll take an example to explain that. Let's say I have 1 0 1 0 1 0 1 1 0 1 0 0 1 0 1 1. So we have this group here, this group here, and this group here. Now I want to just count that how many substrings contain two groups, right? So that suppose I ask you this, that is it possible that in a substring, or wait, let's say we have 0 1 0 0 also, so we have this group also. So I want to ask you that is it possible that um, these two groups, like is it possible that in a substring that these two are the groups in that substring? No. Yeah, correct. Like it is not possible that we skip these two. Like if we are taking these two groups in our substring, then obviously these two will also appear. So in that case, the answer will be no automatically. We got only one move. Yeah, like I was asking that um, can we have these two in our substring? Like we can't have these two because in that case we'll have four groups. We'll also have these two groups. So, and since we want only two groups, so we can't take these two. My point is that we can only take the consecutive ones. Wait a minute. Yeah, so my point is that these are the groups, and we want to take, like we can only take consecutive ones. So the indices are stored in the V. So I'll just iterate over this V, and I'll check, like I'll count the number of subarrays for which, like, first of all, let's say I have these two groups in my subarray. So I need to count that, okay, how many indices, like how many L2R can be there such that these two groups are possible. So how will I do that? I have to select an L and an R. So similar to that question, we can just select L, either this, or this, and R from either this, or this. So in that case, like if we do that, only these two groups will be selected, and these two won't be selected. Understood? Like, is this clear? This is actually a very crucial part of the solution, right? Like, if we choose an L anywhere from this range and then R from this range, sorry, R from this range, like here to here, or actually, we can even choose here, till here, then uh, what I'm saying is my substring will contain exactly these two groups. Okay, so we'll just count these arrows, like the number of indices to the left of this 1 1. We just count them, and we just count uh, these arrows, so like to the right and before the left of this, and we'll multiply them together, and any substring of that type will be our, like, almost alternating substring. Because what if there are three consecutive ones in between the string? Okay, I'll actually talk about that later, or maybe I'll talk about that right now. like say, yeah, first of all, I was saying that I could do this only because this 0 0 and 1 1 were opposite. Like I will only add my answer if these are opposite. If they are the same, then I won't do anything. Like if it was something like 0 0 1 1 0 1 0 1 1 0 1 0 1. So these 1 1, I am iterating over the vector, but I'll check that these ones are same. So I won't add this to our answer. Like ideally, I would have added 3 into 1, 2, 3, 4, 5, 15. 50 into our answer, but I won't do that since this 1 1 are same. All right. So yeah, someone asked that what if there are three consecutive ones in the string? So in that case, that will be handled automatically. Like let's say I have this case 1 1 1 0 0 0, sorry, 0 1 0 1. So in that case, my vector will look like what? I'll use a different color. So my vector will have this group and this group. So when I'm checking, like when I'm iterating over the vector, I will see that this one group is there, okay, and the other group is this. And since they are the same, I won't do anything. And also, like you might ask that this can't occur in substring. Like let's say there was some zeros, there is this, and there is some ones. Or like let's say this is one group of 0 0. So you might think that these three ones might cause a problem, but actually everything works out fine in this case also. Like for example, if we want to find out for this group and this group, left one, then what we will be doing, like what our algorithm will be doing, is that it will count from here to the like next group's first element. Like that's what we are doing, right? If you see correctly, let's say 1 0 0 1 0 1 1 0 1 0 0. So let's say if you want to calculate the answer for this and this, so the right limit would be from here, 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 or here. So like this is a group. So technically, what is it doing? That to find, okay, we are calculating the answer for this, right? If these are the two ones, then the right limit can be anywhere from here, 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 or here. So what it is doing, that it is checking the next interval, like the next group, and till the first element of that group, it is like saying that r can be till there. So even in this case, even in the above case, it works out because you want these two, right? So next one of this is this, and the first element of this group is this element. So you just want till there, and it is correct. So yeah, so that's how we handle the case where, yeah, like you basically need to do that for all the pairs. Like um, in this case, we have one group here, one group here, one group here, one group here. So we calculate the answer for these two. Then we calculate for this and this. Then for this and this. And we'll just add those and get an answer. All right. Like we will get the number of substrings which have two groups, right? So that's it. That was the case for two. Now let's say we have zero. Actually, the one with the one is a little bit tricky. So I'll explain the 0 1 first. Like it has zero groups. So again, it is simpler, I guess. That let's say I have example 1 0 0 1 0 1 0 1 1 0 0. Let's say this is the example. So we have these groups So we want that our substring do not contain any group in them. So actually, if you can see that it becomes similar to the problem that at least one K1, like the person who asked that if the problem was at least 1K occurrence, then I explained that you could just treat them as partition, right? I think it is gone, but like in that problem, it was something like 2, 4, 5, 3, 2, 4, 5, 3, 4. Like if you want the number of subarrays containing at least one 4, or suppose you want the subarrays containing no occurrence of 4, then you can just treat them as a huge partition that it divides it into groups, and you have to choose your L and R from these groups. So the same thing, like a similar thing you can do here, that you don't you don't want any group of doublets, like you don't want any doublets in your subarray. So for each L and R you choose, like either you can choose from these three elements, like from these three elements you can choose either L, like L and R both, or you can choose from these elements both L and R. But if you choose like one from, sorry, uh, let's say you choose one from here and one from here, then in this subarray this 1 1 occurs. That is not what we want. We want only, like we don't want any occurrence of any group, right? So therefore we can either take like any two of these indices, or we can take these ones, like any two of these four, or we can take any two out of these, right? Or we can take these two. Like what I am essentially doing is, for like what I am doing is either my subarray, like my subarray would be between two groups. Like if it doesn't contain any group, then it has to be between two groups, right? So if it is between these two groups, then it can be anywhere from these four indices. That's what I'm doing for every pair of, like for every consecutive pair of groups. I think I may not be clear enough in this. Like if someone wants to explain, someone wants me to explain once again, I'll do that. Like in this thing, we are iterating over the vector, and basically, let's say I am at this one. So I want to count the number of subarrays like this. So I can just do these four indices and 4C2 plus 4. Yeah. So that's the answer for zero groups. Understood, or is it not clear? I think it may be not clear. Is it? Is there anyone who didn't understand? You can tell me. Why did we add 4 to it? Why only 4C2? Okay. Okay, I'll just explain once again the whole thing. So, let's say we have the problem that we are given this array 2, 4, 5, 4, 6, 8, 4, 9, 1, 4, and 3 and 6. And we want the number of subarrays which don't have a 4, right? So how do we find that? We can just, like we have to choose an L and an R, right? So we have to choose them such that in this range a 4 doesn't occur, right? So basically, if you look at these are the 4s in the array. So technically, this array is divided into some parts, different parts. These 5 parts, the array is divided into. And if you take L from one part and R from the other, then definitely you can say that 1 4 is going to be there, right? Do you agree? Yeah, we can't take the L and R from different groups. We have to take them from the same group. So that's what I'm doing. That suppose there is a group of length n1, then there's a 4, then there's a group of length n2, then there's a 4, so and so on. So basically, what I can do is I can either take both the L and R from this n1, so that would be n1 c2 plus n1. Why am I doing plus n1? Because they can be same also. Like L could be equal to R, right? So for this group, like for this part, this is the answer. Like if I choose both L and R from this group, then this is the answer. Or I can choose from this N2, uh, N2 C2. How did I come up with N1 C2 plus N1? You said it would be 2 to the power N1. No, not 2 to the power N1. Actually, we have to choose one subarray. You are thinking subsequence. Like subsequence may not be continuous, but subarray has to be continuous. So we have to just choose two numbers, L and R. That's why I did NC2. But the thing is that they can be equal as well. So they can be equal to any of the n numbers. So I added plus n. Or like you can say n plus 1 C2. I think it is pretty famous, right? That the number of subarrays of an array of size n is n plus 1 C2. So that's what it is essentially. N plus 1 C2 is the same as NC2 plus n. What is that C? The combinations formula. Yeah, combinations. NCR equals n factorial upon. Yeah, I mean it is that one only. Or you can write n into n plus 1 by 2 if you want. Like I am just using the formula for number of subarrays. If if the array length is n, then the number of subarrays is equal to n into n plus 1 by 2. That's what I was saying. So above, like if you have a group of n1 size, then essentially it is an array of n1 length and you have to choose a subarray in this. So you can do that in n1 into n1 plus 1 by 2 ways. That's what I was saying. So I hope it is clear now. Like I hope at least this one is clear, this problem. Like for this problem, any doubt for this sum, like for this problem? Like in this, we can just do the answer to this will be 1 plus 1 plus this is 2 size. So we have like 3 options, then plus 3 plus 3. So for this array, the answer would be 11. So I hope it is clear. Yeah, so this problem is clear. Now now we'll go back to the Codechef problem, which is like we want 0 groups. Right? So I'll take the example 1 0 1 0 0 1 0 1 1 0 1 0 1 0 1 1 0 1 1. Okay. So we have these groups. We have this group right here, this group right here, this group, and this one. I hope I'm not missing anything. Yeah, I'm not missing anything. So what we want is that in our subarray, which is L comma R, we don't want any group to appear. So essentially, what we can say is that this array is also divided into parts. Like we can take this one part, then this is the another part. Sorry, this is another part. This is another part, and this is the last part. Sorry, this is the last part, and yeah, this is one part also. Yeah, so this is the thing that this array gets broken into parts, just like the above. Like in this case, the parts were these: this part, this part, this part, this part, and this part. And basically, we couldn't choose L and R from two different parts. So in this case as well, if we choose L and R from two different parts, then we would end up with some or the other group in our substring. Like if we choose L from here and R from here, then we will get these two groups. Like even though that answer is correct, but we are just counting the number of substrings which have zero groups, which don't have any groups. We are counting that. So to count that, this is the case. Like we have to choose L and R from the same part. So we have, in this case, we have four parts. Five parts. One, two, three, four, and five. And we can do the same thing for this. Like this is four. So 5C2 plus 3 factorial, 2 factorial, 5 factorial, 1 factorial. No, not factorial. Like you have to just choose a subarray. You have to choose L and R from any of these parts. So if you choose from this part, then you have like 5C2 ways. Can't we take 0, 0, 1, 0, 0, 0, 1, 1? Because we need to count almost alternate substrings. Actually, I have counted that in the above thing. Like when I was explaining that for two groups, we have to do what? Like I am separately counting the cases for two group, zero group, and one group. So right now I am counting only the ones with zero groups in it. I already counted two groups. So this case of 0, 0, 1, 0, 1, 1, that would be counted in the two groups case. So I don't have to repeat it. Got it. So yeah, in this case, the answer would be like just this length is n1, this is n2, this is n3, n4, and n5. Then n1c2, sorry, n1 plus 1 c2 plus n1, sorry, n2 plus 1 c2 up to n5 plus 1 c2. So this is the number of subarrays which do not contain any group. So basically, this is the case for 0. This is the answer for 0 groups. We counted for 2. We counted for 2 where? We counted for 2 here. Then we counted for 0 here. What remains is we count for 1. Right? We want one group in our substring. But also, we want it to be almost alternating. So the condition for that was that either the first letter should be different or the last should be different, or like from the group, either the first or last is different. So we'll learn how to count that. We'll see how to count that, right? So we are counting for one group. So let's just say we have this string 0, 1, 0, 0, 0, 1, 0, 1, 1. So we have this group, and this group. So we want just one group in our substring. So yeah, it becomes like that problem only. Again, like we want exactly one occurrence of k in our substring. So how will we do that? Like if we want exactly one occurrence of, like if we want this group to occur in our string, then we can choose L from here, here, or here, and we'll choose R from here, 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 or here. So if we choose our L and R like this, then basically we will have only one group in our substring. Like only this group we will have, right? So we will have 3 into 6, which is 18. But our problem here is that we don't want identical substrings. We don't want the identical endpoints, right? Like suppose I take this L and I take this R, right? So my substring would become 0 1 0 0 1 0. So it has only one group, but it is not almost alternating. That's because the endpoints are same as the group. Like I need at least one endpoint to be different from the group, right? So basically what we are overcounting. Like our thing is not correct. Like we were doing, we could take L from this, and we could take R from this, and this. But the thing is that this is not correct because we are also counting the cases where the endpoints are 0 0, right? So we need to not do that. So what can we do? That's the question. So any ideas out of the people remaining in this meeting? Any ideas? Okay, I'll just tell that. So basically, if we are checking for 0, then we don't want both of them to be 0. So from the total, like the total was 3 into this thing, 6, right? Total was 3 into 6. I'll just subtract the ones ending in both zeros, like where L is also 0 and R is also 0. Like I- L is 0 for this and for this. Like these are the non-permissible values for L. I mean, for these two values, L is 0, and for these three values, this, and this, R is 0. So we can't take both L and R to be this. Like basically, the number of ways of taking both zeros would be just 2, like 1 and 2 into 3, 1, 2, and 3. So we would subtract 2 into 3. Basically, in these substrings, both the endpoints are 0. So we need to subtract these from the 3 into 6. So we will get 12. So in 12 substrings, only this 0 0 occurs as a group, and the substring is like alternating, almost alternating. So that's my point. That's how you count. But the thing is, how will you do it in code? Like you just have a vector, right? You have a vector of indices. So how will you do it? So for example, uh, I think you can easily calculate that how many arrows will be here. Like for 3 into 6, you can easily calculate. Like you can just look at the next group position, and according to that, you can calculate the number of arrows for right, and you can see the previous group position, and according to that, you can calculate the arrows for left. But now you need to subtract. You need to subtract the ones which are same. Like how do I do that? How do I figure it out that how many are same? So actually, for that, it is a very nice trick. Um, let's say we had this 0 ordered set. No, we don't need to do that. We can just use a little bit of maths. Like we had this 0 0. Now, since it is a group, like I know that the previous group is here and the next group is here. So I know that there is no group in between. So we can say that this is 1, this is 0, this is 1, this is 0, this is 1. Like even without storing, we know that all of these are alternating because there is no group in between. So I can say that this is the thing, right? Now for the L, like this is 0 0, this is also 0 0. So for L, I had added like these ranges, and for R, this range, like 1, 2, 3, 4, 5, 6, 7, 7 into 1, 2, 3, 4, 5, 6, 7, 7 into 7, yeah. So 49 minus, we would have to do this 0, this 0, this 0, this 0, 4. 4 into 1, 2, 3, 4, 4. So this is what we would do. But how do we do that? My point is, my point is that you can notice that this range that we would take, it is like alternating only. Like suppose we have 0, 0, then definitely the range would have 1, 0, 1, 0, 1, 0, this type. So we could easily count the number of zeros. Like if it is of length n, then it would have ceiling of n by 2 number of zeros, because it is alternating, right? It starts from 0, then 1, then 0, then 1, then 0, then 1, then 0. So therefore I could say that it has exactly n by 2 ceiling number of zeros. Do you get it? Hmm. Is it clear? I'll just explain once again that let's take an example. 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1, 1. This is, or let's say uh, 0, 0, right? And you are calculating the answer. Sorry. No. Let's say you're calculating for this answer. You're calculating for this group. So basically, what you would do is you would take this interval for L. For interval, you will take this interval for L and this interval for R, right? The length is this is 4. Like for L, the interval length is 4, and for R, the length is 5. 1, 2, 3, 4, 5. And we can see that in this 4 length ka interval, we have two zeros. That is L, like 4 by 2. And in this 5 length ka interval, we have like 5 by 2 ka ceiling. Like we have three zeros, 1, 2, and 3. So we can just do this. And this is the extra amount that we want to subtract. Like this is the number of substrings which end in both zeros, and we don't want to count them. So we can just do this, like n1 into n2. Like n1 and n2 are these lengths of the intervals, and we can subtract ceiling of n1 by 2 into ceiling of n2 by 2. So that's how we count for one group. Like we count the number of substrings containing only one group, and we just add all of these three answers. Like we counted for 1, then above we counted for 0, I think. Yeah, for we counted for 0, and we counted for 2 as well. Here we counted for 2. Where did we count for 2? Yeah, here we counted for 2. So we'll just add these three values and print our answer. So was there any part that you didn't understand from the whole explanation? Is there anything that you want me to repeat? Understood. So anyone else who wants me to repeat anything? Got it. Okay. 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 So I hope everyone got it. Like no one is saying that they didn't. So I'm just assuming that Everyone got it. All right, then I'll just show you the code. Like, I don't think you will understand it as a like understand it right away because it is somewhat complicated. Like, I have just done that. I have made this vector. Actually, I had made this pair also because it's not necessary, but I'm just storing that the group index, and if the group is 0 or 1, like if the group is 0, then I'll just store 0, and if the group is 1, then I'll store 1. Like, I didn't store it. I didn't need to store it because I had the string s, so I could check using that. But okay, then I just initialize the answer to 0. Huh, the edge case is that if V doesn't have like anything, that is, there are no groups in V, then just print all subarrays. Like, all subarrays will be alternating. So just print all of them and return. Otherwise, this is the code for checking. Like, in this one, I am checking two of them. Like, in ith iteration, I am checking for Vi and V of I plus 1. Those two groups, I am counting the number of them, right? And this one is for one group, right? Like, for I am checking that if the ith group is substring is in the substring, then the number of ways of that. And in this loop, I'm like in these three lines, like in these five lines, I'm adding the zero case. Like, this is the case where before the first group, and this is the case for between two groups, and this is the case for after the last group. And I just print the answer. Like, you can determine specifics later. Like, the calculation exact you can do. I just told you the logic. So yeah, that was it. That's how many problems I could do in Div 1. Actually, in Div 1, only three of them were there. So I could do three of them. And yeah, that was it. So I hope you all enjoyed. And any doubt? Does anyone have to ask anything? Okay, if you don't have any doubt, you can leave the meeting. Thanks a lot. Okay, you are welcome. Thanks for the thanks. Okay, all right then. I'll see you next time. Bye bye.